What's up, math fans? I'm sure you saw part one of this video where I talked about the function rules of special triangles or special angles that come from special triangles. So I'm going to remind you real quick what I talked about, and then we're going to get into this one. So those special angles came from a special triangle called an isosceles triangle, where the angles measure 45, 45, 90. So no matter how big you stretch that triangle, it's still isosceles. So the side lengths change, but the angles remain the same. And isosceles means two of the angles have to match. So it's always going to be 45, 45. And of course, I want it to be a right triangle. So the third one is 90. Remember, three angles in a triangle must always add up to 180 degrees. So if the side lengths change, they do stretch, but that's a dilation. So what happens is, even though the lengths are bigger now, the ratios of the lengths remain the same. So what happens is you learn that the sine, cosine, and tangent of those angles always stay the same, because this is what I mean by ratios. The sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Also, if you're checking my work in the calculator, make sure the mode is in degrees. Whenever I put numbers here, 30, 45, and 60, I'm talking about degrees. There is, of course, a mode where you can change it to radians or other things. But that was the isosceles. Then we moved on to an equilateral triangle where all angles are 60. I cut that in half, so now I'm dealing with another special triangle called the 30, 60, 90 triangle, right triangle. And we let the hypotenuse be 2x, and the base is forced to be x because it's half of the original size triangle. So then we needed to explore what the third side measured. And the third side comes from our favorite theorem, the Pythagorean theorem. A squared plus b squared equals c squared. Now I'm going to try to be as specific as I can. So little a is going to be opposite big A. Opposite is down here. So little a is x. I have to square that. And little b is unknown, so I'm going to leave that as little b. It's opposite big B, of course. So big B is here, little b is over there. And little c is opposite big C, so that's my hypotenuse. That's going to be 2x, and I have to square that. So you should know this by now because I did it already. X squared plus b squared equals 2x times 2x is 4x squared. I got to get x alone, so I'm going to bring all my x terms to one side, leave me with b squared equals 3x squared. Take the radical on both sides. Radical and squares cancel out, leaving me with b. I don't know the square root of 3, but I do know the square root of x squared, so that's x radical 3. So that's what I put on my height, or little b, or side opposite of big B. Notice, the side opposite of the 30-degree angle is x. The side opposite the 60-degree angle is x radical 3, and the hypotenuse is 2x. That's in general. If there were specific numbers there, if I put a number here, no matter what number I put here, this is therefore 2 times that number. So if I put 10, this would be 2 times 10, which is 20. If there was a 10 here, this would be 10 radical 3. So if you remember that, it's just a quicker way, so you don't have to do the Pythagorean theorem. You just say, oh, I see this is 5, so I guess this is 10, I guess that's 5 radical 3. You can also work backwards. If this was a 10, you can then figure out that this is 5. Just be careful, if they spin the triangle, you have to spin your knowledge and understand opposite 30 is the x, opposite 90 is the 2x, opposite the 60 is the x radical 3, no matter how they spin it. Alright? So, let's figure out our ratios, also known as our functions. So what's the sine of 30? Now I have to label my sides. So hypotenuse is always opposite the right angle, but when I list opposite and adjacent, it depends what angle. So if I'm talking about 30, I'm going opposite to 30, that's opposite. And adjacent to the 30 is next to the 30, that's going to be my adjacent. So let's see, sine, you got to memorize this SOHCAHTOA thing here. Sine is opposite over hypotenuse, so that's x over x radical 3. Cosine is adjacent over hypotenuse. Wow, I think I made that mistake before. It's x over 2x, excuse me. X over 2x. Okay, cosine 30 is adjacent over hypotenuse, so that's x radical 3 over 2x. And then tangent of 30 is opposite over adjacent, so that's x over x radical 3. Now here, my x's cancel, leaves me with 1/2. Here my x's cancel, leave me with radical 3 over 2. And here my x's cancel, leave me with, be careful, 1 over radical 3. And then you should say, wait a minute, mathematicians don't allow an irrational number in the denominator, so I gotta do a whole nother step where I rationalize the denominator, and I'm sure you've seen that video. So that's gonna be radical 3 over radical 3 times 3 is 9, radical 9, but the square root of 9 is 3. I hope you know your perfect squares. So here, here, and here go here, here, and here. Okay? And I already filled in the 45 for you last time. Now I'm going to prove my answers for the 60, and we're good. Now, if I'm dealing with 60, then I have to rewrite my labels. So I'm going to erase it. Generally, if it was paper and I can't erase it because I used pen, I just cross it out and rewrite it. So if I'm going to deal with 60, here's my 60, so now this becomes opposite, and this is next to the 60, becomes adjacent. Okay, hypotenuse stays the same because it's still the hypotenuse. That doesn't change. So now I'm dealing with 60, 60, and 60. So sine of 60 is opposite over hypotenuse, which is x radical 3 over 2x. Cosine 60 is going to be adjacent over hypotenuse, which is x over 2x. And tangent is going to be opposite over adjacent, which is x radical 3 over x. Okay, you'll notice the sine and the cosine of 60 are the reverses of the sine and the cosine of the 30. That's no coincidence. It's the same triangle. There's only so many choices. So we're going to do what we did. Cancel the x's. I got radical 3 over 2. Cancel the x's. I got 1 over 2. Cancel the x's. I got radical 3. This time it was on top, so there's no need to rationalize. Just fill it in. And if you study this table long enough, and I hope you do because it's going to get bigger, I'm going to add other numbers to it. I'm going to add 0 degrees, I'm going to add 90 degrees. But if you study it, you'll notice a pattern. You'll notice these match, you'll notice these match, you'll notice these match, you'll notice this divided by this is 1. You'll notice a lot of different things. You'll notice that you can just count 1, 2, 3, 3, 2, 1. But the denominator always stays the same. Alright? So a lot of different things happen. Don't panic that I used x's. If you use your favorite number, the same thing happens. They'll still eventually cancel out, giving you the same ratio no matter how big that triangle was. Alright? Thanks for watching. See ya.